Everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please do the problem, pause, come back, and we will try to do it here. Okay, here we have two rational expressions, and you have to add them. Yuck. It's called common denominator. And the equivalent to the sum for all x greater than negative 2. Okay, well, if x is 3, you have a problem. But we won't sort of worry about that right now.
Also a problem when x is negative 3.
Well, but x has to be greater than negative 2, so we don't have to worry about x is negative 3. Anyway, looks to me like we're going to have to add these things. I mean, there may be a fancy way of doing it, but maybe the best thing is just to factor this. Now, you know there's going to be a 3 here, because there's a 3 here. We're sort of guessing. But this would have to be a 6. Oh, look at that. It works. Oh, my God. Look at that. It works. It works. It works. Look at that. It's easy to factor. You sort of cheat because this is
let's
x
make it clear what you're doing.
And x minus 3.
So
the bottom line is, this
polynomial is equal to this one.
That's right. So let's clean it up.
It's really the denominator of this guy is equal to x plus 3 times x minus 3.
That's right. Now, why are we doing all this?
Just what's equal to what?
Wait.
And
Seth, let's talk first about why we're doing all this. Because when you add fractions, you have to use a common denominator. If you add a third plus a fifth, you need a common denominator of a 15th. So in order to get the common denominator, we need the factors of these denominators. And then we can decide what the common denominator will be. Okay, that's what we're heading toward, right? So
sometimes you don't need it.
That's right. Sometimes you don't need it. The question is
so again, I like to point out patterns. The pattern that we see immediately is that x minus 3 is a factor in both of these denominators.
That's right.
And so, my next step would be to see what happens when we factor it out.
Oh, that's sort of clever. That cleans it up a little bit.
It's a matter of applying the strategy of detecting special patterns in an SAT question.
Right.
So now I have a much simpler rational, and I bet what's going to happen is that when you add them and put them under a common denominator, what's going to happen is the numerator will cancel one of the factors of the common denominator.
That's right, because the denominators here are very simple.
They're not because the denominators here they're not very, so they're degree 2.
Right, exactly.
But if you did the routine operation of calculating the common denominator for these two denominators, you do is by multiplying all the factors, get a common multiple, the least common multiple, you're going to get a cubic.
That's right. Yeah, because
and this guy, the denominator is a quadratic. And
so let's start doing.
And so what I bet's going to happen is this thing's going to become. So let's do it. So let's calculate this out.
Times x plus 6 over x plus 6 plus 1 over x plus 6, and then x minus 3. Here, I wouldn't cut corners. I would invest the time because you want to get the question right.
Yeah.
Now, I guess we could cut corners here. This is 2x plus 12. Notice there's no minus sign. Check that out. The gift plus x minus 3 divided by x minus 3 x plus 6.
Times x plus 6.
Yeah, we're running out of space. So this is 3x.
So let's just
3x plus
put this
9.
here.
3x plus x. 9. Yeah, we got it. It's 3x plus 9.
Yeah, 3x plus 9 is equal to 3 times x plus 3.
Right, so let's just change that to 3
and the x
times
plus 3
x plus
cancels.
3. So we have the x plus 3's cancel, and we have a 3 on top. All the answers, no, forget that. All the answers have a 3. No, all the answers but one have a 3, and then this is the denominator. So, for the benefit of everyone, we'll probably write that up a little neater. So, here. So, Seth and I went a little fast at the end. So, let's slow down a little and write it a little neater. Okay, we have 3x plus 9 divided by x plus 3 times this thing, x minus 3, x plus 6. Seth
times x plus 6.
Seth did greatest common factor. He pulled out the 3, and this is x plus 3. We're almost there. We're almost there, everyone. X minus 3 times x plus 6. You cross off these, and you're left with the final answer is 3 divided by x minus 3 times x plus 6. Unfortunately, more than one answer has a 3, so you actually have to multiply this out. And this is x squared plus 3x minus 18, and that's that. By some people use the word FOIL, some people hate the word FOIL, but you multiply these two things out, and you get this, and so that's the answer.
Well, there's another pattern.
Yeah.
That lets us quickly choose. Notice that. You multiply to get the constant term. Get minus 3 times 6 is minus 18.
That's true.
And the only choice that has a minus 18 in the denominator is that one.
You're right. Oh, yeah, I forgot that. You are totally
However,
correct.
I did not notice that at first.
Yeah.
So what I did was... Yeah. So what I did was check...
That's right.
These two. Yeah. Okay.
Yeah, that's true. Now, the question is, so this is really done, really, the straight way, straight arrow way. You just, you factor the denominators. You use a common denominator. Seth did use the trick here, which was very nice, of pulling this out. If you don't do that, then you're left with more complicated calculations. Yeah. In fact, you're left with a lot more complicated calculations. Is there any quick, clever, super clever way of doing this other than what Seth did, which, by the way, is really clever, and we'll show why at the end? I mean, I don't know. Well, the amount of time it may take you to figure out if there's a really quick, clever way of doing this may be equal to the amount of time that you actually have to just do it straight.
Oh, well, clever way that involves, well, no, I can't see a clever way that's any faster than what we did.
Yeah, now why?
Besides factoring out the x minus 3.
Yeah, but that's...
But, the thought about combining that with a clever way is to identify what are called the poles.
Yeah, but that's...
Which are the values of x where a denominator in a rational function becomes 0. And you could see where they are immediately. For the first term, it's plus or minus 3. But the second term, it's harder to see where the poles are without factoring it.
Yeah, right.
And finding the poles, means that you completely factor.
Yeah.
So I think the a necessary calculation to solve this problem, which is pretty easy calculation with the numbers they gave. It's a key part of solving this problem is to factor the second denominator. And there's an 18 and a 9 and 18 are kind of 9-ish or 3-ish. Right? So just factor and searching for the factors. Factors of 18 is 2 times 9, but you can't get the middle term by adding or subtracting 2 and 9. So try the other one, 6 and 3. Well, 6 and 3. Yeah, that's cool. The 6 plus 3 equals 9. So it's x plus 6 and x plus 3.
Wait, what did I'm redoing the problem. What did I do wrong? Here, I'm redoing the problem without the factoring the x plus 3 out. This is 3x. This is 3x. This is a 6 minus 3, which only adds a 3, which is 3x plus 1, which can't be right. But anyway, it turns out that it wasn't totally necessary. You don't save that much time pulling out the x plus 3.
What do you say, 3x?
What?
There's a minus. Oh, no. There's 3x. 2x plus 1x is 3x. And 2 times 3 is minus 6.
Oh, to 12. Oh, my bad. I didn't distribute.
Yeah.
It's a 12. Yeah, I always say negative signs in distributing. That's where you make all your mistakes. Yeah. But yeah, maybe Seth is right, because adding this has less baggage than doing it this way. Plus, you have to carry this x plus 3 thing around. I mean, who wants to carry this x plus 3 thing around all over the place? But yeah, so yeah, this does look more complicated, and it leads to more mistakes. See, it didn't distribute that. But if you did it this way, you would realize you'd get a mistake. Ooh, they should have. I guess they couldn't have done it, but they should have made a distractor where this would be the answer, just in case for those people who don't distribute right.
Yeah. Now, dealing with this expression, let me make the space right over here. So in orange, the lower left corner, everybody, 2 over x minus 3 plus x. I'm sorry. I'll set the back. Undo. Yeah. Right. So let's see, what am I doing? What
plus 1 over x plus 6.
1 over x plus 6. Rather than actually writing 2 times the quantity x plus 6. Rather than doing this is how I think about this. I directly multiply the 2 by the x and the 2 by the 6.
Right.
To get 2x plus 2 times 6 is 12.
Right.
And then for this guy, I directly multiply the x by 1 and the minus 3 by 1.
Right.
So I get x minus 3.
Right. Yeah.
No, the thing is, the mistake you made, you actually wrote down 2 times x plus 6.
Right.
And then what you translate that to is 2x plus 6.
Right. Yes. Exactly. I made a mistake distributing. Yeah.
So it's bad. I think it's better to combine the mechanics of distributing the 2 times the x plus 6 right away.
Right. Yeah.
Effectively you are looking at the same symbols.
Right.
But you're not writing extra stuff.
Right. Yeah.
Where the distraction of writing the extra stuff can lead you to make a mistake.
That's true. But you got to be careful. I mean, that comes with more experience, and which you should get when studying for the SAT and when doing math. You should develop more experience. Yeah, that comes from, let's say, 2/5 plus 7/3. So you're saying that this is 6 plus 35/15, because you do 6 and then you do 35.
Yeah.
Right. Yeah. Yeah. That comes with experience. Essentially. Yeah. 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 That's a good pattern to remember. But yeah. Okay. So let's see how
Well, there's
they.
what's nice. The what mathematicians like is a pattern like this: a over b. Let's say a over x plus b over y.
Yeah.
What is that? That is equal to. That's equal to
Well, ay plus bx
ay
over ay plus bx
bx
divided by xy.
over xy.
Yeah. Yeah, that's very nice. But after a while, that's nice. You have one thing to remember, but then you add on another thing to remember. Then you add on another thing to remember. All of a sudden, if you don't do it all the time, it's not really practical to remember a lot of stuff. So,
But when you do it all the time, it is. When you do it all the time, you do it better when you remember a lot of stuff.
yeah, I know, but our audience isn't doing math all the time. Seth has a PhD in math from MIT, and
so you learn these with your little tricks.
Yeah. So when
you have ready to use when
right.
you.
Yeah. So when you're studying for the SAT, these are good tricks to keep in mind. Absolutely. Yeah. Okay. It also helps in regular school too. So let's see how they do it. They'll probably do it the straight arrow way. Okay. We never really paid attention to that restriction of x greater than -2. Okay, so here we go, step-by-step solution. 6 steps. You know what that means? That means you can't do this problem in 3 seconds. And don't try to do this problem in 3 seconds. Okay, they're trying to get step 1, least common denominator. You have to factor first. Yeah, so then they did it my way. They didn't do it Seth's way. And also they didn't pull out the common x plus 3 like Seth did. See, they kept the x plus 3, sort of like how I did at the end. And then they don't do that little trick that you pulled because that's not their audience. And then they just did it straight arrow way, just totally straight arrow way.
Well, the explanation they give is good for learning or reviewing the ideas and the facts that are involved in the problem. But when you're taking the SAT, you would never do the questions quickly enough to get a high grade if you write out all the stuff.
That's right.
That they wrote as an explanation.
Yep, that's right. So that's a disconnect between the solutions that they offer and the reality of getting this thing done in a reasonable in the time limit. Yeah. So I guess the answer to that is do enough of these so that you get faster and faster at them. They had to also make the. Now, are they going overboard on this restriction? Couldn't they have just said that x can't equal -3? Couldn't they have just said that?
Yeah.
They could have. They didn't have to go overboard with this x greater than -2 thing. They could have just said this, right? X can't be -3 and leave it at that. But Seth's right. When you're doing these problems, you would run out. Probably would have run out of time if you did every single problem like this. So you have to be careful about that. That's why you need to do a lot of practice.
The sum that they gave, go back to the top of the statement. Okay. Yeah, this thing is this sum here. Well, the issue with -3 is that when x equals -3, this denominator, this becomes a 0, and
no, x plus 3 becomes 0.
Yeah.
The other one. Yeah.
This becomes a 0,
right?
And this one becomes a 0,
right?
So you have these two. Each individual term has a pole and x equals minus 3. It's also called the singularity. But when you add them, what happens is the parts of the function that are singular, that go to infinity when you approach minus 3, cancel.
Yep.
So what we teach in mathematics is that this function, defined by adding the left side to the right side, has what is called a removable singularity at x of minus 3.
Right.
In other words, so that means is that if you plot it at x equals minus 3, what's going to happen is you get a curve, something like this. It's going to go to 0. No, so it's not going to go to 0. It's going to go, and then what happens is it's undefined.
Yep.
It's undefined, bad at x equals minus 3. But the curve kind of ends at the point where x equals minus 3 from the left, and it continuously and differentiably on the other side.
Yeah.
And so by redefining the function so that it is defined at x equals minus 3, we get a nice function. It's, it's well defined, it's fat continuous and differentiable. All that. So we call call minus 3 the location of a removable singularity.
Right.
Let's remove it.
Yeah. Okay, and there's one last thing. This happens on virtually every SAT, ACT test, is knowing how to factor the difference of two perfect squares. There seems to be this thing always comes up. We'll make it a nice big thing, because it is a big thing, because it comes up on virtually every SAT, ACT test. If you have a squared minus b squared and you want to factor that, it factors to a plus b, a minus b. That's how they factored this x squared minus 9 so quickly, and that's how we did it, because this is x plus 3, x minus 3. You definitely...
What's behind that? What's behind that business? Well, what's behind that business is that there are two terms that come from multiplying this out.
Right.
It's four terms, but two of them cancel.
Right.
This one is minus AB, and this one is plus BA, which is equal to plus AB.
Yep.
And they cancel.
Yep.
And then the remaining two terms, there's an A multiplied by a positive A to get an A squared. And then there's a B multiplied by a negative B to get a minus B squared.
Right. Yeah. We can't talk enough about the difference of two perfect squares, because it's virtually guaranteed to come up on every test. Now, also, this is interesting because there's a way to view it too. If you have the equation x squared minus x squared is equal to 9, x squared is equal to 9, we know that x is equal to plus or minus 3. But you could also solve it by moving the 9 over and setting it to 0. X squared minus 9 is equal to 0. Then you do the difference of two perfect squares, and you see that x is equal to 3. X plus 3 and x minus 3 equals 0. And then you can view it this way, and you see that x is equal to plus or minus 3. So that's another way to view this whole difference of two perfect squares, and maybe this is why it comes up so much, because equations like this come up a lot, where you do x squared is 25, x squared is 100, x squared is 144, and you can solve it directly, or you could bring it over to bring the 144 or the 9 over to make it 0, right? 144 is equal to 0, and then factor it, or you just see that the answer is plus or minus 12. Okay, so difference of two perfect squares, ultra important. Anything else, Seth? We're done?
When you say perfect square, it makes me ask, well, what is an imperfect square?
Look, this is what they call it, okay? You can argue with the people who call it.
It depends, this concept of factoring. The concept of factoring here actually depends on the number system that you are using.
Okay, Seth, enough, I think. I think enough.
Yeah.
I think enough.
No, some people might think of things like this. X squared minus 3. What's the solutions? Well, people are taught plus or minus the square root of 3.
You mean
and so you could write x squared equals 3 as the solution to as the equation. X squared minus 3 equals 0. And you could, and if you're allowed, if you use a number system that includes, irrational square roots, you could factor this as x plus the square root of 3,
right,
times x minus the square root of 3.
Right, that's right.
So in other words, 3 is equal to the square root of 3 squared.
Right.
So if your number system includes irrational square roots, then 3 is a square.
Right. 3 is the square of the square root of 3.
Is it perfect?
Right. 3 is the square of the square root of 3. Right.
Yeah. Of the square. Yeah.
Change your perspective. Perfect. Okay, so I think we really are done today.
Really done. Yeah.
Really done. This is Seth Chaiken. He has a PhD in math from MIT. You probably can tell by his super sophisticated ways of doing things. And he's a professor emeritus of computer science in SUNY Albany. I have a PhD in mechanical engineering. I take maybe more from more practical approaches, get the problem done. We're here to hopefully show you how to do SAT math questions. And our approach in studying is to at least go to Khan Academy. And where they offer 2 classes, one the digital SAT class, the non-digital SAT. Figure out which test you're going to take. Go to Khan Academy. They have hundreds and hundreds and hundreds of questions that are sanctioned by the SAT people, and it's a great way to prepare. And of course, as you get closer to the test, you want to prepare. You want to take actual SAT tests that are provided by the College Board. Okay.
Well, I say the approach I think both of us share is to learn enough math so that you know what the SAT problems are talking about.
Yeah, that's right.
Know what the problems are talking about, and then when you think and calculate, then you know what you are thinking about and know what you're calculating.
Right. Yes.
So if you explain it to someone, you will be able to explain it to someone, and you will know what you're talking about.
Yep. So that's right. Okay, I think we're done for today. So have a great day, everyone. Like us, dislike us, give us comments on our YouTube videos. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them live online here. Take care, everyone. Bye.
Bye-bye.